I hope you're having a great day. I want to go over with you and review with you adding and subtracting like fractions. And what is the definition of a like fraction? It's any fractions that have the same denominator. Okay, so the size of the pieces are the same. And there's different models and tools that we can use to help us see how this process works. Of course, I've got my magnetic fractions that we use at school a lot. And then I've also got those bars, these bars as well that we use at school, and the fraction pies at school. But let's say you don't have that at your disposal at home. There are other tools that could be found in your kitchen that might be able to help you really visualize what it means to add like fractions. And I actually took out my kids' Easter eggs that they painted over the weekend and thought, well, this will be a great way to model adding like fractions in real life. Because if this is my whole carton, okay, how many equal pieces is my carton divided into? Since this is an average carton, there's 2, 4, 6, 8, 10, 12. 12 individual pieces, 12 individual eggs. And some of them are colored differently, right? So I could ask myself questions like, I don't know if you can see this very well. If you see these 3 up here, there's 3 pinks colored. Okay, so my kids painted 3 pink eggs. Okay, so how many parts of the egg carton are painted pink? Hopefully you know to recognize that as the fraction 3/12. 3/12 of the eggs are pink. Okay, so not all the eggs are pink. The whole carton is not pink, so I can't say the whole carton. I can't say 12/12, but 3 of them are. Top 3 up there. So if I ask the question, how many eggs in my egg carton are pink and orange? Or what part of the carton are both pink and orange? Probably be the better question to ask. So if I have 3/12 of my egg carton is pink, and then down here I see that 2 out of 12 eggs are orange. 2/12 are orange. How much of the whole egg carton is pink and orange? Is the whole egg carton pink and orange? No. Only part of it. How many parts? Well, since we have 12 equal parts, we're dealing with 12s, right? Each one of these eggs is like a 12. So my parts remain the same. So when you're adding like fractions, your denominator remains the same. And that's what makes adding like fractions pretty simple when you're learning them in 4th grade. Okay? But this is so fundamental to understand that when you add fractions, you want the size of the pieces to be the same so you can count up the number of pieces that you're trying to identify. So how many eggs are pink and orange out of the carton? Now we're going to add the 3 plus the 2. 3 plus the 2 is the 5. But the whole carton is not pink and orange. Only 5/12 of the carton is pink and orange. Okay? So 5/12 of the carton are pink and orange. So that's adding like fractions. When you have 2 denominators that are the same, the denominator stays the same when you're adding, and you're just simply adding the total number of parts that you're identifying. Okay? Some other things that you might have in your kitchen that could help you with adding and subtracting like fractions is a measuring cup. However, the labels on a measuring cup might be a little trickier because this is something that you have to understand, and it's going to be really hard to see since this is clear. if you look at the bottom, on this measuring cup, this is a large one, but on smaller measuring cups, they usually start at fourths, okay? So they actually start at a half on this one, and I know that's really hard to see, and you can't see that very well. And then it goes to 3/4, and then 1 whole, and then 1 1/4, and 1 1/2, then 1 3/4 to 2 cups, to 2 1/4. So it's counting by fourths after it gets to that half, but you'll notice that they're not calling the halves by fourths. But what is a half and fourths? Hopefully by now that's a very common thing that you just think about automatically. You don't have to give it much thought, but 2/4 is the same as a half. So, and then when they get to the whole cups, how much is a whole in fourths? Hopefully by now you've learned that when the numerator and denominator are the same, that's when you would have wholes. So 4/4 is a whole. And then the next whole would be 2 wholes, which would be 8/4, and so on. So that is also something that you might have in your kitchen that could help you understand adding and subtracting like fractions a little better. Some other things that you could do is make a pizza, and think about when you cut the pizza and everybody from your family eats different amounts of pizza, add up all the total number of slices that each person eats. And usually people cut pizzas into 8 slices, so eighths. So let's say, I'm going to get this out here. Let's say that I think actually my family ate some pizza last night. We ate some frozen pizza. I wasn't feeling too well yesterday, and so my husband made some frozen pizza for my kiddos and for himself last night. And I actually ended up eating a piece or two because I was feeling a little bit better. I think I had a reaction to a vaccine that I got at my doctor's visit on Monday. I don't think I have any kind of things to worry about because I'm feeling better today, but I just felt very weak and had a headache yesterday, and but I'm feeling much better today, so I don't think I have anything to be worried about. And that's a common thing that can happen when you take a vaccine, especially when you're pregnant and your body's just different. So I think I'm all right, so don't worry about me. But anyway, the pizza scenario. So when my husband cut up the pizza last night, he cut it into eighths, so 8 equal pieces. And so I'm trying to think about how much each person ate of that pizza. And honestly, I think I ended up eating 2 slices. So I'm going to put T for Tabitha, because that's my first name. Okay. So I ate 2/8 of the pizza. I don't think there was any leftovers last night. And I don't think Selma ate any. She's not really into pizza. She'll eat pizza every now and then, but she likes pizza rolls more. So I think she had pizza rolls last night. Asher, I think he ate 2 slices. He might have eaten 3. Sometimes he's really hungry. Let's just say he ate 3. And then my husband ate. He ate 3 as well. Because we didn't have any leftovers. Okay? So I'm kind of labeling how much each person ate. So I ate 2/8. Asher ate 2/8. And Brandon ate, no, Asher ate 3/8. Sorry. And Brandon ate 3/8. How much of the pizza did we eat in all together? Okay, so our size of pieces are eighths. Since that is a like fraction, okay, it's going to be easy. All of these are like fractions. It's going to be easy to count up how much we ate in all. So how many eighths did we eat in all? 2 plus 3 is 5, plus 3 is 8. We ate 8/8 of the pizza, which means we ate the whole darn thing, right? So we ate 1 whole pizza. All right, so adding like fractions, pretty simple, right? So let me just put that out there. Let me just put this out here because this is what you're going to be encountering in 5th grade. What happens when your denominators are not the same? Let's say that we didn't cut this pizza into equal parts. let's say Tabitha ate 1/4 of the pizza, and Asher and Brandon ate 3/8 of the pizza. How does this change that? That's something to consider as we move later on in 5th grade into adding fractions that do not have the same denominator. So it's really important as a 4th grader to understand that when you're adding like fractions, it's really simple because you're just adding up the total number of those size pieces that you have in all. So the denominator remains the same, and you're just counting up the numerators. So it's pretty simple. Let's take a look at a subtraction problem, and also I want to make sure that you understand how to complete this worksheet option if you have chosen option number 1 for assignment 5. Okay, so let's try a subtraction problem. You guys want to use the egg cartons? All right. So I have my egg carton here, and it's filled to the brim, right? Let's say I take out this white one. This is one that we did not paint. We actually had one that busted, and so we didn't paint it. So I don't have 12/12 in here. I have 11/12. So I'm going to write 11/12 up here. And let's say that I say 2/12 of the eggs are green. And then I ask the question, how much of the carton is not green? That would turn that into a subtraction problem, finding the difference problem. Because we know there's 11/12 in all. Okay, so this is kind of like a number bond problem. We know there's 11/12 in all. And we know that 2/12 are green. I want to know how many are not green. How many are not green? So I'm finding the difference. So I'm going to be subtracting 2/12 from this amount. So 11/12 are in my carton to start out with. That's my total, 11/12. And I remove 2/12 that are green. So when I remove those out, how much of the carton is left over? Well, each one of these eggs counts as a 12th of the carton. 1/12, 2/12, 3/12, 4/12, 5/12, 6/12, 7/12, 8/12, 9/12. And if you think about it, 11 minus 2 is 9. And notice the denominator remained the same because the size of our pieces remained the same throughout. So adding and subtracting with like fractions seems like too easy, too good to be true, right? As long as you understand the concept that the denominator tells us the size of the pieces and the numerator tells us how many of those pieces that we're identifying, okay? That's crucial. So that's why I put that work in your NTI for this time, is because I want you to continue thinking about that and practicing that and not forgetting, because in 5th grade it's going to be coming up where you don't have the same denominators. And some of you have already kind of figured out how to solve addition and subtraction when the denominators are not the same. And I applaud you on that. I'm so excited because you're definitely making connections. So I'm very proud of you guys. So real quick before I let you go, let's take a look at this work from your NTI. I kind of split it in half there to show you that the subtraction's at the top and the additions is on the bottom, because I didn't want you to get mixed up of what you were doing. And I also drew in some visual models too. You don't have to do the visual models. They're just there to help you. I think sometimes drawing out the pictures really helps, or using specific models like the egg carton really does help. So 1/2 minus 1/2. Hopefully, when you really think about that, you start out with a half a candy bar. You eat half a candy bar. How much candy bar do you have left? You have 0 halves left. You have absolutely no candy bar left, right? So let's take a look at this next problem just to be thinking. 4, 6 minus 2, 6. What could be a story about 4, 6 minus 2, 6? Well, sometimes egg cartons come in just half a dozen. So they just come in 6 eggs, right? So imagine you have 4, 6 eggs. Okay, so I have 6 equal parts, and I start with 4 eggs there. So 4, 6. So I'm not even starting out with a whole half carton of eggs, right? And I remove 2, 6. How many 6 are left? It's going to be 2, 6, right? I don't know if I'm confusing you anymore because I'm taking this egg carton and trying to show half a dozen, but I can get my 4, 6 up here. And since the 6 are all the same size, I can just remove 2 of them, like it says, right? 4, 6, 4, 6, remove 2, 6, and you have 2, 6 left over, okay? And you can draw a picture out if you need to. Now the bottom is adding. By the way, up here on my picture, you'll notice that when I drew my picture, I shaded in the amount that I started with, and then I X'd out what I got rid of. That's how I showed subtraction, okay? Down here at the bottom, however, when I showed addition, I made 2 separate holes and shaded in 2/5 of one hole and 2/5 of another hole, and showed how when combined together, 2/5 plus 2/5 almost make a hole together, but not quite. It still leaves 1/5 open, so together it makes 4/5. So I don't really anticipate that you'll have many problems with that, but like I said, I want you reviewing this because I know it's coming up in 5th grade, and I want to make sure you have this as a foundation and we're not forgetting about it. The back of that sheet are 2 story problems you have to do. Remember, the challenges are always optional, okay? Make sure you do RDW. Read carefully. Underline, circle things that are important from the story. Make a plan. If you want to go ahead and write out an equation to help you solve it, that's always a great way to start your plan. And then you need to show your work by drawing a picture. That's where that D comes from. Drawing a picture, or doing using numbers or words to show your thinking through the problem, and then writing a solution statement, RDW. Read, draw a picture, use numbers, or write words, and then write a solution statement, okay? So make sure you complete that. If you decided to do Cynthia's perfect punch, okay, that should be fun, and you can kind of act it out if you want to. Uses gallons, so I don't know how many of you have things that measure in gallons at home, but it should be kind of fun if you choose to do that. So anyway, adding and subtracting like fractions, it's not so bad. So hope you enjoy the rest of your day, and I will catch up with you and talk to you later. Bye.